In the question here, we are asked to find the surface area of this portion here in green color. Let's say green color portion equal to x. If this PQRS here is a square-shaped quadrilateral, P here is the center of the circle, and this line Q bisects this angle PQS. Bisect means divides into two equal halves. That means this angle here must be equal to this angle here. We know that the four angles of a square are right angles, which is 90 degrees. So therefore, this and this must be 90 degrees over 2 each. And 90 degrees over 2 is 45 degrees. And here, this point A is the midpoint of line PQ. So that means line AP must be equal to line AQ. Here, the length of arc AB is 7.86 centimeters. So how can we solve this now? This is very simple and straightforward. From this PQRS here, this triangle BRS, triangle CQS, this ABP here, and this shape here make up the surface area of the quadrilateral PQRS. So if you sum up the individual surface areas, they must be equal to the surface area of the quadrilateral PQRS. So we can form an equation that area of triangle BRS plus area of CQS plus area of ABP plus area of X equal to area of PQRS. Now since we are solving for the area of X, we make it the subject of the formula. Now area of X equal to area of PQRS minus area of BRS minus area of CQS minus area of ABP. So what is the area of the square PQRS? The formula for the surface area of a square is the square of the length of one of each side. So area of PQRS equal to L squared. What is the length of each side? We don't know. But coming back here, if you look, this line AP is drawn from the center of the circle to the circumference, and that implies that line AP is a radius. So recall from here now that the length of this arc AB is 7.86 centimeters, and the formula for the length of an arc is theta over 360 times 2 pi r. So we can equate 7.86 to theta over 360 times 2 pi r to find the radius. Theta is the angle is subtend to the center, which is this angle here. And we already said earlier that the angles of a square are right angles, which means this here is a right angle. So therefore, theta equal to 90 degrees. This here 22 over 7. So 7.86 equal to 90 over 360 times 2 times 22 over 7 times r. 90 over 360 is 0.25. 22 over 7 is 3.143. So 7.86 equal to 0.25 times 2 times 3.143 r. 0.25 times 2 times 3.143 times r equal to 1.5715 r. So 7.86 equal to 1.5715 r. Making out the subject, we divide both sides by 1.5715. So 7.86 over 1.5715 equal to 1.5715 r over 1.5715. Here 1.5715 cancels 1.575, and 7.86 over 1.5715 equal to 5.0016, which approximately equal to 5. So therefore radius equal to 5 centimeters. And we have here that line AP is a radius which equal to 5 centimeters. So now if you come back here, we have line AP equal to line AQ. So therefore line AQ also equal to 5 centimeters. But line PQ as a whole is one of the sides of the quadrilateral PQRS, and the length of line PQ is 5 centimeters plus 5 centimeters, which equal to 10 centimeters. So substituting it here now, area of PQRS equal to 10 squared, which equal to 100. So area of PQRS equal to 100 centimeters squared. Substituting here now, area of x equal to 100 centimeters squared minus area of PRS minus area of CQS minus area of ABP. So now what is the area of triangle BRS here? Triangle BRS is a right angle triangle because we know this angle here is a right angle. The formula for the of a triangle is half base times height, and in a right angle triangle, any of the two sides that are perpendicular to each other can be taken as the base or the height. So let's say this BR here equal to base and this here equal to height. So what is the length of line BR and line RS? So from this quadrilateral here, since this is a square-shaped quadrilateral, we know that all the sides of a square are equal in length. So since this line PQ is 10 cm in length, this line QS, line RS, and line PR must also be 10 cm in length each. So now, from this, we can substitute directly that height equal to 10 centimeters. So now what is the base here? If you look here, since line BP is also a radius because it was drawn from the center to the circumference, and the radius of the circle is 5 centimeters, that means line BP is also 5 centimeters. And if line BP is 5 centimeters in length, this line BR must be 10 minus 5 centimeters, which is 5 centimeters. So base 9 equal to 5 centimeters. And we found the height to be 10 centimeters. So substituting into this equation here, area of BRS equal to 1 over 2 times 5 times 10, which equal to 25. So area of BRS equal to 25 centimeters squared. Substituting it here now, area of x equal to 100 centimeters squared minus 25 centimeters squared minus area of CQS minus area of BP. 100 centimeters squared minus 25 centimeters squared is 75 centimeters squared. So area of x equal to 75 centimeters squared minus area of CQS minus area of ABP. Now coming back to the area of ABP. ABP here is the sector of this circle here. And the formula for the area of the sector of a circle is theta over 360 pi r squared. So area of ABP equal to theta over 360 pi r squared, where theta is the angle at the center, which is this angle here, 90 degrees. Pi is 22 over 7, and r is radius, which we found to be 5 centimeters. So area of ABP equal to 90 over 360 times 22 over 7 times 5 squared, which if you press your calculator equal to 19.6429, approximately equal to 19.64. So area of ABP equal to 19.64 centimeters squared. Substitute it here now. Area of x equal to 75 centimeters squared minus area of CQS minus 19.64 centimeters squared, which is the same as area of x equal to 75 centimeters squared minus 19.64 centimeters squared minus area of CQS. 75 centimeters squared minus 19.64 centimeters squared is 55.36 centimeters squared. So area of x equal to 55.36 centimeters squared minus area of CQS. So now, to find the area of CQS now, we need the length of each side. And for that, we need the size of the angle. Here we have this angle here to be 45. So what is this angle here and this angle? We don't know. But from this triangle here, we can find the side of this angle here using the SOHCAHTOA tool. Now from this angle here in question, this here is the opposite because it's facing the subject angle. This here the adjacent. So now tan theta equal to opposite over adjacent, where opposite is 5 centimeters, adjacent 10 centimeters, and therefore tan theta equal to 5 over 10, which is 0.5. So tan theta equal to 0.5. To find the value of theta, we find the tan inverse of 0.5. So theta equal to tan inverse of 0.5, which equal to 26.5651, approximately equal to 27 degrees. So this angle here is 27 degrees. And if this angle is 27 degrees, this must be 90 degrees minus 27 degrees, because the angles of a square are right angles. 90 degree minus 27 degree is 63 degree. So now since this is 60 degree and this is 45 degree, this must be 180 minus 63 minus 45, because the sum of angles in a triangle is equal to 180 degree. 180 degree minus 45 degree minus 63 degree is equal to 72 degree. So this angle here is 72 degree. Now since we have the length of this side here and the sides of the angles of the triangle, we can use the sine rule to find the length of this side here. Now applying the sine rule, line QS over sine 72 degree equal to line CQ over sine 60 degree equal to line CS over sine 45 degree. Line QS is 10 centimeters. So taking this part now, 10 over sine 72 degree equal to line CQ over sine 60 degree. Making line CQ the subject, line CQ equal to 10 over sine 72 degree times sine 63 degree, which if you press your calculator equal to 9.3686, approximately equal to 9.37. So line CQ equal to 9.37 centimeters. Now taking this part here, 9.37 over sine 63 degree equal to line CS over sine 45 degree. Making line CS the subject, line CS equal to 9.37 over sine 63 degree times sine 45 degree, which if you press your calculator equal to 7.4361, approximately equal to 7.44. So line CS equal to 7.44 centimeters. Now to find the surface area now, since we have the length of all the sides, we can apply the Heron's formula. By Heron, if the length of the sides of a triangle are A, B, and C, the area of the triangle is square root of S times S minus A times S minus B times S minus C, where S equal to A plus B plus C all over 2. So letting this equal to A here, and this B, and this here C, A equal to 10 centimeters, B equal to 9.37 centimeters, and C equal to 7.44 centimeters. So substituting here to find S equal to 10 plus 9.37 plus 7.44 all over 2, which equal to 13.405. So substituting all the values here now, area equal to square root of 13.405, open bracket 13.405 minus 10, open bracket 13.405 minus 9.37, open bracket 13.405 minus 7.44, which if you press your calculator equal to 33.1451, approximately equal to 33.15. So area of CQS now equal to 33.15 centimeters squared. Go ahead and substitute it here now. Area of X equal to 55.36 centimeters squared minus 33.15 centimeters squared, which equal to 22.21 centimeters squared. So area of X equal to 22.21 centimeters squared. And X we know is representing the green colored portion. We are asked to find its area. So this here is 22.21 centimeters squared approximately. Asked to find the total surface area of the blue colored portion, which is this here and this. Let's label this A and this B. Here, if the circumference of the circle is 31.43 centimeters, the angle subtended by this arc PQ here to the center is 130 degree, and the angle subtended by RS to the center is 70 degree. So now, how can we solve this? We can see here that this is 73 degree. Since we have already labeled this to be A and this to be B, we can let the total surface area of the blue colored portion to be X, and form an equation that the area of X is equal to the area of A plus area of B. So what is the area of A? A here we can see is a segment of this circle here. So how can we find its area? If you look at this sector, it is made up of this segment A here and this triangle, and that implies that the total surface area of the sector is equal to the area of this segment here plus the area of this triangle here. So now area of sector equal to area of segment plus area of triangle. From here, we can make the area of the segment the subject of the formula by subtracting the area of triangle from both sides. So area of sector minus area of triangle now equal to area of segment plus area of triangle minus area of triangle. Here, area of triangle minus area of triangle is 0. So area of sector now minus area of triangle equal to area of segment, which is the same as area of segment equal to area of sector minus area of triangle. But what is the area of sector? The general formula for the area of the sector is theta over 360 pi r squared. Theta is the angle it makes with the center, which is this angle here. So theta equal to 130 degrees. Pi is 22 over 7. So now area of sector equal to 130 over 360 times 22 over 7 times r squared. But what is r? R is the radius. So what is the radius of the circle? We don't have it. But here we have the circumference of the circle to be 31.43 centimeters. And the formula for the circumference of a circle is 2 pi r. So we can equate 31.43 centimeters to 2 pi r. Now 31.43 equal to 2 pi r, which is the same as 2 pi r equal to 31.43. Pi is 22 over 7. So 2 times 22 over 7 times r is equal to 31.43. 2 times 22 over 7 is 6.286. So 6.286 r equal to 31.43. Making r the subject, we divide both sides by 6.286. So 6.286 r over 6.286 equal to 31.43 over 6.286. Here, 6.286 cancels 6.286. And here, if you press your calculator, 31.43 over 6.286 is 5. So therefore, radius equal to 5 centimeters. We can go ahead and substitute it here in this equation. Now, area of sector equal to 130 over 360 times 22 over 7 times 5 squared, which if you press your calculator is equal to 28.373. So area of sector now equal to 28.373 centimeters squared. Substituting here, now area of segment equal to 28.373 centimeters squared minus area of triangle. So what is the area of triangle? To find the area of triangle, we can use the Heron's formula. By Heron, if the sides of a triangle are A, B, and C, then the area of triangle must be equal to square root of S open bracket S minus A open bracket S minus B open bracket S minus C, where S equal to A plus B plus C all over 2. So we can let this side to be equal to A, this B, and this C. But this is a radius, and this is also a radius. And earlier we found the radius of the circle to be 5 centimeters. So that means this and this are 5 centimeters in length. So we can substitute from here A equal to 5 centimeters and B equal to 5 centimeters. But what is C? C is representing the length of this side here, which is a chord of this circle here. So how can we find its length? The formula for finding the length of a chord is 2r sine theta over 2. So line PQ now equal to 2r sine theta over 2, where theta is the angle it subtends to the center, which is this angle here, and r is the radius, which we have to be 5 centimeters. So line PQ now equal to 2 times 5 sine 130 over 2. 130 over 2 is 65 degree. So line PQ equal to 2 times 5 sine 65 degree, which if you press your calculator equal to 9.06 centimeters. And if the length of line PQ is 9.06 centimeters, that means C equal to 9.06 centimeters. And here we have A equal to 5 centimeters and B equal to 5 centimeters. So substituting here now to find the area of the triangle, area of triangle equal to square root of S open bracket S minus 5 open bracket S minus 5 open bracket S minus 9.06. But what is S? S here equal to A plus B plus C over 2. So substituting A equal to 5, B equal to 5 and C equal to 9.06 here, S equal to 5 plus 9.06 all over 2, which if you press your calculator equal to 9.53. So substituting here now, area of triangle equal to square root of 9.53 times 9.53 minus 5 times 9.53 minus 5 times 9.53 minus 9.06, which if you press your calculator equal to 9.59. So area of triangle equal to 9.59 centimeters squared. So substituting here now, area of segment A equal to 28.37 centimeters squared minus 9.59 centimeters squared, which is equal to 18.78 centimeters squared. So area of segment A now equal to 18.78 centimeters squared. Substitute it here now. Area of X equal to 18.78 centimeters squared plus area of B. So what is the area of B now? B is this portion here in blue. So how can you find its area? From this triangle here, if we remove the area of this segment of this circle here, we are going to be left with only the area of this B here. So we can let this segment here equal to K and form an equation that area of B equal to area of triangle RST minus area of segment K. So now, what is the area of segment K? Recall here, the angle subtended by its arc to the center is 70 degree. So from the sector now, if we subtract the area of the triangle now, we are going to be left with only the area of this segment K here. So area of segment K equal to area of sector minus area of triangle. The formula for the area of a sector is theta over 360 pi r squared. Theta is the angle at the center, which is this angle here, 70 degree. Pi is 22 over 7. And r is the radius of the circle, which we have here to be 5 centimeters. So area of sector now equal to 70 over 360 times 22 over 7 times 5 squared, which is equal to 15.28. So area of sector equal to 15.28 centimeters squared. Substitute here now. Area of segment K equal to 15.28 centimeters squared minus area of triangle. So what is the area of triangle? The area of this triangle here can be calculated using the Heron's formula, which we stated earlier. So letting this side to be A, this here B and this C. Side A and B are radii, and we have the radius here to be 5 centimeters. So therefore, A equal to 5 centimeters and B equal to 5 centimeters. But what is C? We don't have its length. But since side C is a chord of this circle here, and the formula for finding the length of a chord in a circle is 2r sine theta over 2, we can say C equal to 2r sine theta over 2. R is the radius, which is 5 centimeters, and theta is the angle subtended to the center, which is this here. So C equal to 2 times 5 times sine 70 over 2, which if you press your calculator equal to 5.74. So C equal to 5.74 centimeters. And we have A equal to 5 centimeters, B equal to 5 centimeters. So coming back here to S, since S equal to A plus B plus C over 2, substituting the values now, S equal to 5 plus 5 plus 5.74 over 2, which is equal to 7.87. So now substituting the values into this equation now, area of triangle is equal to square root of 7.87 open bracket 7.87 minus 5 times 7.87 minus 5 times 7.87 minus 5.74, which if you press your calculator equal to 11.75. So area of triangle equal to 11.75 centimeters squared. Substituting here now, area of segment equal to 15.28 centimeters squared minus 11.75 centimeters squared, which is equal to 3.53 centimeters squared. Substituting here now, area of B equal to area of triangle RST minus 3.53 centimeters squared. So now what is area of triangle RST? We can still use the Heron's formula if we have the length of the side, but we only have the length of this side here. But using sine rule, if we have the sizes of the angles of the triangle, we can find the length of the sides. But what are the sizes of the angles? We don't have them, but we can calculate them. So coming back here, since this angle here is 73 degrees, and you have here that the angle subtended to the center by this RS here is 70 degrees, based on the circle theory that the angle at the center is twice the angle at the circumference if subtended by the same arc, we can draw a line from here to this point here. So if you look, this angle here is subtended by this arc to the circumference, and here we are told that the angle is subtended to the center is 70 degrees. So from this here, this angle is half of 70 degrees, which is 35 degrees. But recall here, the size of this whole angle is degree, and we found this part to be 35 degrees. So this must be 73 degrees minus 35 degrees, which is 38 degrees. So if you look here also, this angle is an angle subtended by this arc PQ here, and here we have the angle subtended by the arc to the center to be 130 degrees. So applying this rule here, this must be half of 130 degrees, which is 65 degrees. So now from this quadrilateral here, we know that in any quadrilateral which has 4 of its vertices to be touching the circumference of a circle, the sum of opposite angle must be equal to 180 degrees. So that means the sum of this angle here and this angle must be equal to 180 degrees. So we can label this side of the angle to be equal to y and form an equation that 35 plus 38 degrees plus 65 degrees plus y equal to 180 degrees. 35 plus 38 plus 65 is 138. So 138 plus y equal to 180 degrees. Subtracting 138 from both sides, y is equal to 180 degrees minus 138, which is 42 degrees. So y equal to 42 degrees. Substitute here. Coming back here also, these three angles align on the same straight line, and we know that the sum of angles on a straight line must be sum of 180 degrees. So we can label this h and form an equation that's 65 plus 42 plus h equal to 180 degrees. 65 plus 42 is 107. So 107 plus h equal to 180 degrees. Subtract 107 from both sides now. H equal to 180 degrees minus 107, which is 73 degrees. So h equal to 73 degrees. Substitute it here now. Coming back to this triangle here, since the sum of angles in a triangle is equal to 180 degrees, and we have this to be 35 degrees, this to be 42 plus 73 degrees, This must be 180 minus 35 minus 42 minus 73, which is 30 degree. Now coming back to this triangle RST here, since we have this to be and this to be 30 degree, this must be 180 minus 73 minus 30 degree, which if you press your calculator equal to 73 degree. So now we have the angles of the triangle and the length of this side here. So using sine rule now, line RS over sine 30 degree equal to line ST over sine 77 degree, which is equal to line RT over sine 70 degree. RS is 5.74. Taking only this here, 5.74 over sine 30 equal to line ST over sine 77 degree. So making line ST the subject, line ST equal to 5.74 over sine 30 degree, all multiplied by sine 77 degree, which is 11.19. So line ST now equal to 11.19 centimeters. Now taking this here, line ST over sine 77 degree equal to line RT over sine 73 degree. Line ST we found to be 11.19. So 11.19 over sine 77 degree now equal to line RT over sine 73 degree. Making line RT the subject, line RT equal to 11.19 over sine 77 degree, all multiplied by sine 73 degree, which if you press your calculator equal to 10.98. So line RT now equal to 10.98 centimeters. Now we have the length of all the sides. So using the Heron formula now, we can let this equal to A, this B, and this C. So now A equal to 5.74, B equal to 11.19, and C equal to 10.98. Substituting here now, S equal to 5.74 plus 11.19 plus 10.98 all over 2, which if you press your calculator equal to 13.955. Substituting all here into this equation, area of triangle RST is equal to square root of 13.955 open bracket 13.955 minus 5.74 open bracket 13.955 minus 11.19 open bracket 18.955 minus 10.98, which if you press your calculator equal to 30.71. So area of triangle RST now equal to 30.71 centimeters squared. Substituting here now into this equation, AB equal to 30.71 centimeters squared minus 3.53 centimeters squared, which is equal to 27.18. AB equal to 27.18 centimeters squared. Now if you come back to the original equation here, substituting area of V equal to 27.18, area of X now equal to 18.78 centimeters squared plus 27.18 centimeters squared, which is equal to 45.96 centimeters squared. And recall, X is representing the total surface area of the blue colored portion. So therefore, the total surface area of the blue colored portion now is 45.96 centimeters squared. Thank you.